So, not 116. AJAX and polling. So I changed the order of the lectures this week a little bit to get through the homework content sooner rather than later. It will be a little out of order. In hindsight, I would switch application objective 3 and 2, just swap them. So today we're going to be doing application objective 3, and then on Wednesday we'll do application objective 2, and then on Friday it's not related to the homework at all. We're just going to build some browser extensions and have some fun. So learning objective 1, you've been able to do that for a while. Learning objective 2, we've mostly had for a while, except for the buffer stuff that we talked about. Application objective 1, we have all this stuff. We did buffers. I even found time to do the demo on Friday with the /r/n stuff. I don't intend on distributing images that have the /r/n in them. I don't know. If a TA did, I don't think I'd be too mad if they did release something. But I have no intent on doing that. I won't ask the TAs to do it or anything. The intent is that you'll one, just be able to write your code and not do splitting on these byte sequences. Just bless you. Just being careful about them. But 2, you should be able to set up your own test cases with these. I think that's well within reason to expect in a 300 level CSE course. I feel like I say that a lot, but you made it this far. You made it through at least 115, 116, and 220. And eventually, I got to add, 250. Eventually, I got to add 220 as a prereq to this course. It was when I created this course, 220 didn't quite exist yet, so I couldn't add it as a prereq. But ideally, 220 as well. You're capable of getting this byte sequence in an image. If you want to know the rundown, I said it briefly in one lecture, but just to spend a little more time on it, the way I generated my test cases, I should say, and the way I generated the demo that I showed when I broke some images, is open up the image, the bytes of the image in a hex editor, go into the bytes, and just type your characters. You'll want to look up the hex values for /r/n, which we did last time. Break an image. ODOA. You go into a hex editor, you go into the bytes of the image, and you literally type 0A0D, and do it twice for good measure, 0A0D to get your /r/n/r/n. And then you have an image with that test case. I found it helps to make sure you're overwriting 2 or 4 bytes, depending on what test case you're setting up. Actually, overwrite the bytes. Don't change the size of the image, because the headers of the image are going to have metadata that says like the height and width of the image. If you actually add bytes, it's going to throw everything off, and it won't be a valid JPEG. It might not be a valid JPEG anymore, or GIF, or whatever image type you're working with. So I would overwrite 4 bytes with those values, and then you have your test image. It shouldn't, depending on your file format, it shouldn't actually noticeably change the image itself, but you'll have a test case that you can use to test your server to make sure you're not chopping up an image. But those bytes, /r is just 0D as hex, and /n is 0A as hex. So just put those bytes in your images, and you have a test case. Even if you do break your image, honestly, if you break your image and it doesn't render after you go into the hex editor, you can still check the bytes, kind of like I did on Friday. You can check the bytes of the original image and check the number of bytes in the image that you saved, and those should be identical. If the one you saved is significantly less, you chopped up your image. So that's how you can test that one, to check for that. That's what we'll be doing on the grading side. So we're done with that. I'm done talking about application objective 1, except questions, obviously, as always. I have no planned lecture content about it, but if there are questions, I'll be happy to answer them. Today we'll talk about application objective 3, which, in my opinion, depends how you approach it, I guess. It's probably the hardest application objective on the homework. It deserves the AO3 slot, even though I just said I would have switched the 2, just for the order of content. But this is what we'll talk about today. We want to set up the same site that we have for homework 2, the same functionality. You can upload images with captions. But if somebody else has the page open and someone uploads an image with a caption, this person doesn't have to refresh the page to be able to see the new post. That's what we want today, which is a very nice feature to have. Some you would expect in most websites that you go to, where you have live interaction with people. And then on Wednesday, we'll talk about cross-site request forgery tokens, which mechanically in your code isn't too hard. I'll talk about the theory behind it and why we do it. And then, like I said, on Friday, we'll just build some browser extensions. This is probably my favorite lecture all semester. I don't ask you to do anything with this on the homework or on your project. It's just a day where we have fun and break some stuff and build some things. So with that, AJAX and polling. Let's talk about it. Is AO1 for homework testing us on anything besides buffer knowledge? Homework 2. Yeah, just the buffer stuff and the /r/n stuff. Just making sure you're being robust. Because if an image has that byte sequence, making sure you're not breaking it up. Really, AO1 is just that. It's the make it robust application objective. So if you're not buffering properly and you're vulnerable to, I shouldn't say vulnerable, but if people can't upload large images, or if somebody happens to upload an image with the /r/n in it, and you're not handling that properly and you're breaking it apart, you're going to have some upset users, you're going to have bugs, you're going to have lots of complaints. You're going to be busy if you release that app to even hundreds of users. They're going to find those bugs pretty quick. It's not too uncommon to have the /r/n in an image. I found that by accident. Just the first time I ran this assignment, I didn't even think about it, because why would you ever split on /r/n when you have the bytes of an image? And then the TAs were grading the first time we ran this assignment, and a lot of students' code was breaking, and I was like, what the hell's going on? Like, it's a common thing to find. It's not. It wasn't uncommon to find a lot of images with that. So application objective 1 is the robust one. Can you actually handle whatever your users are going to throw at you? And the answer is still going to be no, but we're going to get at least close. Because you're going to say JPEGs only, and somebody's going to upload a PDF, and it won't render right. But that's a different thing. So yeah, AO1 is the robustness objective. AJAX and polling. So what we want is user interaction. It's really the goal of I'll say most apps, but when you go to a website, mostly what you're looking for is users engaging with other users. I think that's fairly fair to say, unless you're going to just a website where you're just there to consume some information. Maybe you're reading a blog post. Like, that's something we do. It's fine. But that's not really a web app. It's a web page. If we're building a web app, it's for users to interact with each other. And we have a pretty big problem right now. Not necessarily a problem, but somebody submits a form, they upload an image to your homework 2 code, and the page reloads, and then they get all the information after that reload. Now, what happens after that reload? You're just sitting there staring at the page, and somebody else posts another image. How do we see that image? What do we expect our users to do? Do we expect them to hit there and mash refresh like you do after you submit to AutoLab? Which is something we'll get rid of that eventually, I swear. But is that what we expect the users to do? Just sit there and hit refresh all the time to see the new posts? I hope not. What we want is our site to update. We want the new information without requesting a refresh. You're used to this on the internet. You go to a page, you go to, think of any chat app ever, Slack or Discord or whatever. You expect to just see the new messages as they come in. Hell, these days we even get so-and-so is typing in our chat apps. Like, we want immediate feedback on what's happening with our other fellow humans. So we'd want to build just like a chat app. That's going to be the goal for our lecture, at least that we'll walk through on the slides. And if we have time, I'll just build it live. But we want a chat app where users can send messages and they see each other's messages immediately. Not immediately, but without having to take any action. It might not... What the hell is bouncing down here? Save anyway. So we want to be able to see those new messages without taking any action. We don't want to ask our users to do anything to see the new messages. And our solution to that is going to be AJAX, at least for now. AJAX, Asynchronous JavaScript and XML. The acronym kind of, we got this and XML from the old days when XML was still a big thing. But Asynchronous JavaScript, AJAX. This is a way to make an HTTP request after the page loads. So you can write JavaScript that runs in your app that's going to make more HTTP requests after the page loads. This gives us a lot of power. So after the page loads, we can communicate with our server still. Instead of having, where normally the user would have to take an action. The user would either have to click a link, submit a form, or just type in the URL bar. You know, they have to take some action to be able to talk to your server again. This lets you write code that's going to talk to your server after the page loads. To do that, we're going to create this XML HTTP request object, which I wish they would rename. Give me an alias for that, a different class that just extends that one. Does the same exact thing with a better name. Just call it AJAX request, and then we could remember it better. But XML HTTP request, and then to send the request, we're going to call the open method first. That's going to take the method type for the HTTP request and the path where we're going to send the HTTP request. And then we send it. And that's it. That's sending an HTTP request to the server. So when we send that, on our server side, we're going to get this AJAX request that was sent through JavaScript that was built using this XML HTTP request object. What your server is going to do to handle that as a special case of this AJAX request is absolutely nothing different. When you get an AJAX request, it's just an HTTP request. That's it. You handle it like any other request ever. You're going to look at the method type and the path. You're going to go probably at this point still into your big elif block. One of those is going to hit, and then you're going to process whatever the request is, and then you're going to send some response with send all and send the response. That's it. Nothing is different on the server side. This is strictly a front-end thing. I hesitate to say trick. This is a front-end feature that lets us send extra HTTP requests without asking the browser to send a request. That came out wrong. But without having the user having to ask the browser to make a request. We, in our code, are going to ask the browser to make a request. And then we have this big block in the middle. This monster, which makes sense. I'll explain it all, but when you first see it, it's just a garbled mess of stuff. But you should be able to understand this one. Let me walk you through it. The request object has an instance variable called onReadyStateChange that takes a function. So we're using a little sprinkling of functional programming here. And this function is called whenever the ready state changes. JavaScript is built to be event-based. So the event of the ready state of this request changing, whenever that happens, it's going to call this function and say, hey, the ready state changed. The ready state is stored where this, in this context, is the request. The ready state is stored in an instance variable of the request, and it can be one of several different values, integer values. I forget what they all are, but it's if the request wasn't sent yet, actually I might remember what they all are. If the request wasn't sent yet, if it was sent but we haven't gotten a response yet, if we've gotten a response but we're buffering, and for the one that I remember because it's the one we're really interested in, for, if the ready state is for, that means we sent the request, we got the response, we're done buffering, we have the entire response, and we're ready to rock with it. We're ready to go, ready to read this response and do something with it. So for means we're done with all the buffering and everything. Just like you do in your servers, the browser has to buffer when it gets your response. it has to read the content length and buffer until it reads that many bytes from the body of the response. So 4 means we're done with all of that. We also have the status. This is the HTTP response code that was sent. So depending on what you expect as a response code, this might be something different, but usually you're going to check if this is 200. If we got a 200 OK response, everything went great, then we're ready to parse this response. So if we're done buffering, we got the whole response, and the response code was 200, so we didn't get any 404, 403, no 300 level redirects or even 500 level. We didn't get any errors or anything. Everything went normal, and we're ready to parse these things. Then we run the code inside this if block and actually do whatever we're going to do with the response. This .response, the response variable in the request object, is going to be the body of the response. So the browser already looked at all the headers, parsed everything, checked the content type, all that good stuff, and then response is just the body of the response. So we don't have to mess with any HTTP stuff on the client side. Of course, we could. Actually, can we? Do we even have access to any of that? But even if we can or not, I wouldn't have you do it because this is a back-end class. I answered that a while ago. If we want to send a post request, very similar setup. We just change get to post, and then when we call send, instead of calling send with an empty argument list, we're going to call send with whatever the hell we want to send. Usually we're going to speak JSON when we're talking over the internet. So we're going to speak JSON. I'm going to send a JSON string with whatever I want to send, fire that off to the server, and then when I get the response, do whatever I'm going to do with the response. I'm just printing, by the way, the response to the screen here. This is where you would actually do the stuff. Whatever you're doing, there's some reason, if you're sending an AJAX request, there's some reason why you're sending that request. This is, whatever that reason is, this is what you're going to do with that response. Or sometimes you're sending a request just to send data and you don't want to do anything with the response. You just wouldn't do anything here. You could omit this whole thing if you want, if you're just sending information to the server. Great. We make HTTP requests to the server after the page loads. This is what you all wanted, right? We all wanted this. Okay, why? A few things. One, and we've talked about this. I kind of went on tangents a few times and talked about this, but this is the part where it comes up naturally in the course, is faster page loads. You request a page. You're an internet user, and you've seen this all the time. You request a page. The server responds with just the HTML for the structure of the page, and that's about it. I guess maybe the CSS too, to give it a little styling. And then the JavaScript is sent as well. You run the JavaScript on your code. You have your HTML, which is basically an empty page, and then the JavaScript runs and fires off a whole bunch of AJAX requests. Those AJAX requests come back with the actual data that's going to fill up this HTML. And then when you get that data, then we start populating the page. And those requests, the reason this is a big speed up is those requests usually require a lot of database lookups or a lot of other expensive operations. If you're on some social media site, to populate that content takes a lot of work because it's got to go, one, you request HTTP request to the server. Server gets your request. Server's going to say, who dis? It's got to go to the database, look up who you are, pull your profile. Then it's going to take your profile, it's going to send that to the algorithm, which is going to do a whole bunch of AI and bullshit, and then spit out, this is the content that you want to show this user, go back to the database, get all of that content, accumulate it, and then fire it off back to the client. That takes a while. Not any incredible amount of time, probably less than a second in a lot of cases, but a lot of time for a computer to be processing stuff. It takes a while. A lot longer than, hey, give me your HTML, here's the HTML, which is probably cached on the server somewhere. Might even be cached locally on your page, on your computer if you've been to that site before, fairly recently. So all this operation takes a while. So we want to see something just as humans. It's our human nature. We want to see something right away. We want to know that the server is responding. So you get HTML with a whole bunch of loading icons all over the place, and then slowly your content starts populating. It's a much better user experience when you get the page loading a lot faster. You're less likely to navigate away from that site. Whereas if you go to the site and they're doing what we're doing so far, they're rendering the whole HTML server side and then sending the final page all in one go. By the time they're waiting for you to run your algorithms and talk to your database 100 times, the user is looking at just a loading screen, whatever the browser shows, the loading icon up in the tab, for up to a full second or even more sometimes. A lot of users are going to navigate away and say, well, the site must be down. A lot of times I'll just navigate away, unless it's something I'm interested in. But if it's like, oh, I saw a post on Reddit and I want to click on it and see what it's all about, I'm giving up after a second. I don't know about y'all, but I'm navigating away. And we want, these page reloads can be tough. Even in my demos, when I'm just punching in a comment and then clicking send. In my demos when I was showing this site, I forget what I was even showing that time, HTML templates, I think, at the time. Every time I sent a message, the page reloads, which isn't the worst thing, I guess, but it scrolled up to the top of the page every time. And I had to scroll back down to the bottom, type in another comment, it goes back to the top of the page, because it's a whole fresh reload, and I have to scroll back down. That can be annoying for a lot of reasons. You might get some flickering. If it's reloading a lot, that might really disrupt the user experience. And if you're typing, depending on how you have everything set up, there are ways to avoid this that get a little bit tricky. But if you're typing in a form, you're filling out a form, or you're just typing your chat message, and the page reloads in the middle of you typing that message, well, your message is gone. You got to start over and type again and try to get there before the page reloads again. So reloading the page is annoying. Can also clutter up your browsing history depending on how you got it all set up, and how you're going to stream anything if you have to reload the page every time. So AJAX can solve a lot of these things. Not quite the streaming thing. Well, actually, it can solve the streaming thing as well. But AJAX can get rid of all these issues by firing off an HTTP request, getting more content without requiring a page reload. So this is something that it's pretty ubiquitous on the internet these days. Like, this is just something we do. And if you go to, can I do a quick demo? Kind of sick of slides for the moment. If we go to, like, not 312, not one of my sites right now. Let's go to buffalo.edu. Let's pick on UB. Go to inspect element. Network and refresh. Like, the page is loaded. Page is already here. Oh, of course, UB isn't going to do it now. What's like any site ever? I can't even think of a site right now. What site should I go to? YouTube. Private window. I don't know if I'm logged in or not, but just to be safe. You ever go to YouTube on a private window when it doesn't have your account or anything? The things that it shows people who are brand new to YouTube always, kind of depresses me. Bug bites. I mean, this one's fine. I feel like everybody gets recommended this no matter what your browsing history is. You'll always get lo-fi radio. Actually, let's go here. But we can see how many requests are being sent after the page loads. This is constant AJAX requests being fired off and getting more information from the server. And whenever you see this XHR, those are actually these should all be AJAX requests except the images. The images are the chat icons. But it's constant AJAX requests. Yes. So the question is, how's chat working? They are using long polling. I did not know that. So you see these requests. Let's go to timing. Waiting for server response, 65 milliseconds, a decent amount of time. 30 milliseconds. A quarter of a second stalled. Initial, oh no, that's not server response. Waiting for server response, 51 seconds. So we have a lot of these calls which are taking a decent amount of time. This should be chat. Yeah, watch time. No, we can do this. Yeah, stats, quote. Oh, I'm still in sorted by status. I'm going to sort by waterfall. Here we go. Get live chat. I'm not even looking in the right spot. Get live chat. Timing. Here, we waited an eighth of a second for the server to respond. A response, we got some chat, I'm sure. So it looks like it's actually using something we're going to talk about is long polling. But you notice what I was looking for there? Get live chat. Did I get that one? 400 milliseconds to get a response from the server to get the next chat message. That's an eternity. 0.4 of a second just to get chat messages. That's forever. 1/10 of a second. Get live chat. 1/10 of a second. 1/10 of a second. 1/10 of a second. All right. Well, come on. Give me another slow one. That's even faster. Stop it. 0.2 of a second. We might just got lucky getting a slow one at first. So I can go back to the slides. 87. Well, we saw a slow one at least. So what that's doing is sending AJAX requests to get the new chat messages, and just firing off an AJAX request, getting the new messages, firing off a request, getting the new messages, and it continuously does that to get the chat. Depending on what site you use, like if you go to Twitch, the chat is WebSockets. There were no WebSockets on that page. I surprisingly never looked at how YouTube does chat. Apparently they do long polling. Facebook also does long polling, which is the last topic in my slides. We will talk about that, how that works, which is why I spent so much time in there. But yeah, that's why we use AJAX. Still music playing. Jackie's gonna hate me. He's gotta edit the video. I don't know if he'll have to mute that whole section or not. Think I can steal? Think they'll claim copyright on the lo-fi hip hop? They do? What's that? Is it? Okay, I hope so. Or else, well, if lectures aren't on YouTube anymore, you'll know what happened. All right. So let's send more complicated AJAX requests. Usually we'll just send JSON strings with our AJAX requests, and we'll receive AJAX strings. It's just how we communicate over the internet. But we can send the data from our form the way we have been. If we want to send our form data in an AJAX request, and by the way, I want to give a disclaimer. If you're doing application objective 3, you don't have to do this part of it. This is optional. The sending information to the server with AJAX is optional. What you have to set up for application objective 3 is receiving information from the server. So this part is optional for the homework, but it's relevant to the conversation, so I want to make sure I cover it. Is if you want to send information using AJAX that's submitted through a form, you can use this on submit, which is going to be called whenever the submit action is taken, which is when the user clicks submit. You can run any JavaScript you want here. So I'm going to call my JavaScript function, which we'll see on the next slide, send message with form, and then add this return false. What return false does is shuts down the normal submit form behavior. When you usually submit a form, it's going to send an HTTP request, and whatever that request responds with, it reloads the page with that response. So when for your homework, the user submits the form, gets the 300 level response, and then redirects, follows that response, and reloads the page that way. Return false is going to shut that down and say, hey, don't do your normal stuff. I got this covered with JavaScript. Don't do your thing. Don't do your HTML form stuff. In JavaScript, my send message with form method, I'm going to remove all the ready state changes. That's just for the slide to make it more compact. But we have our post request to some path. And this form data, if you want to read the data from your form, we can get the element for our form, where our form had ID my form. We can get that element and then create a new form data object with that element as an argument in the constructor. That's going to give us all that data in a format that send is just ready to take and then fire off that request. So this is a way we can use AJAX, kind of bypass the form itself if for whatever reason you want to do that, and then send an AJAX request with the same format as our multipart form stuff. This will be follow all the same, whatever our form is, multipart form data in this case. They'll send that information using multipart form encoding and then fire it off as an AJAX request. So if you want that form to be asynchronous, you do this to have those set without requiring a page reload. More commonly, we're going to use JSON. So it's common to sometimes not even use a form. A lot of times I might not even use a form element in my HTML. I'll have some inputs and then a regular old button, an actual button HTML element. And then on that button click, I'm going to call some JavaScript. And then that JavaScript is going to go to my elements, only one in this case, go to my elements, read the values, and then format my own JSON or my own JavaScript object, and then convert it to JSON to send it over the internet. So you have a lot of options on the front end. There's lots of front end stuff we can do to be able to format our data or do whatever we want with our data before firing it off to the server. So those are a few options that we have. And this brings up the next, a big question that we really talked about more so than other semesters. We really kind of talked about a bit just with the questions that I got of when do we render content? So far what we've seen is HTML templates that are rendered server-side. You render the whole thing, you fire it off. But we've also talked about getting requests from the client and then just serving raw data and then having the client render that data and render things client-side. So there are trade-offs between these two. Which, since we talked about this so much, I want to skip some of this. But we just serve raw data and render that stuff client-side. This helps because what if you want to write an app that doesn't use HTML? You want a native mobile app, you want a Roku app, you want an Xbox app. You write that code for that app for the front end and then have it fire off AJAX requests, or probably not even AJAX at that point, but whatever you want to, whatever code, whatever libraries you have to send off HTTP requests, and then hit the endpoints to serve the raw data, and then have the client render the data. If you want to write a desktop app too, you want to write a JavaFX app, you can write HTTP code to fire off the request, get a big JSON string, parse that, get all the information out of it, and then render it however you render it for that specific platform. So now you're not held down to just HTML and just web apps. You can write any kind of app you want. As long as you have an internet connection, you can connect to the API, get the data, and then render that data however you want for that specific app. So for example, Netflix, you can get Netflix on just about any platform these days, and it mostly looks the same no matter what platform you're using. If it's a smart TV or your phone or whatever it is, it looks very similar, but Netflix built a separate front end for every single one of those platforms. It's completely different code for each platform. I mean, they probably got some ways to share between certain platforms, but a lot of them are going to be specifically written front ends for that platform, but they only have one API. There's only one Netflix that's hosting all of the movie content, all the movie and shows and everything. There's only one server, and you just hit the endpoints. All those apps hit the same endpoints and get the data from the same place. There's only one, they only write the code once to handle authentication. It gets your HTTP requests, your login requests. It responds with, yes or no or tokens and whatever. And then you consume the API after that. So a lot of different front ends, but the same back end all the time. That's the way any big app works. If you have a lot of apps on different platforms, that's the way they work, is through the API. And it's usually JSON. Any questions on anything so far? Oh, these are new questions. If you are disabling page reloads or redirects for AJAX, how to send 400-level response redirects? Good question. So we're not disabling reloads or redirects, but we are kind of taking that power away from ourselves with AJAX. So an AJAX response can respond with a 400-level error. Good question that I actually don't know. You meant 300. But the one question I don't know, if your AJAX request responds with a 300 level, does the browser see that and redirect? Honestly, I haven't tried that. I don't know. What happened to my... Oh, there's just something wrong with my brain. For the homework, do you want it to reload when you hit the submit button and the polling for getting updates, or no reloads for both? For for most of the homework, you don't have to care about any of this. But when you get to application objective 3, it's okay for a reload when you hit submit, as long as it's polling to get updates. So yes, what you said is accurate. If you want to get rid of the reloads for submitting too, go for it, but it's not a requirement of the homework. It's not a requirement for AO3. As we're talking about polling, we should probably talk about polling. So there's still a problem with this. Like, how do you trigger an AJAX request? How do you get an AJAX request to go to do its thing? Do you want the user to hit a button? Because that button might as well be the refresh button. Our goal is to have the AJAX request send off without the user having to do anything. We want our code to just fire off AJAX requests. And the simplest answer, and a very common answer, is to do polling, which means send an AJAX request at some fixed interval and just keep sending them. Just send them, send them, send them. This is pretty straightforward to set up. We use setInterval. This is built into JavaScript. This takes a function to be called and the amount of time to wait between function calls. So this is saying every 1 second, call get messages. And then every second, it's going to call get messages, get messages, get messages. It's just going to keep calling it over and over again till forever. And that's polling. So if your get messages is sending the AJAX request and then rendering the response into your messages section of your web app, that's going to update every second with that AJAX request. So get messages, send AJAX requests, And then once you have that method set up, it's as easy as calling set interval, and you have polling. There is one downside. This isn't this isn't like a universal solution. The users have to wait up to, in this example, 1 second to get their content. If the timing is just off, the worst case, you're waiting a whole second, which it's not terrible, right? But depending on what you're doing. If it's a chat app, sure. You can wait a second for that message to come in. What if you're playing an MMO? You're going to have 1 full second of lag every single frame. Like you're going to get basically 1 FPS. That's not going to work. So you can decrease the polling rate. So you could just change 1,000 to 100, for example. But now you're sending off 10 requests per second. That's going to start really loading down your server. If you have a lot of users doing this, I actually accidentally DDoSed myself doing this before. I had a chat app. It was in, I think, CSE 113 back when that still existed. And I just had a chat app set up with 1 second polling with 1 second intervals. And there were, 100 students in the class. Maybe 50 of them actually used the app at the time. And I gave the demo during lecture, and I said, hey, everybody use the chat app. And they all typed dumb stuff in there and giggled about it and stuff. And all of a sudden it stopped working, halfway through lecture. I'm like, oh, what the hell happened? I was hosting on a DigitalOcean site, on a DigitalOcean droplet, and DigitalOcean actually sent me an email, and they said, hey, we got your back. We detected a DDoS attack from UB, so we shut down your server. We actually blocked that IP address, their block of IP addresses, so they can't send you messages anymore. You're welcome. I'm like, dude, what the hell? That was me. I wanted to use that. And I started crunching the numbers. I'm like, wait, 1 second. Let's see, that's 60 per second. If they're using it for, or 60 per minute. If they're using it for half an hour, I'm making the math hard. 1,800 requests per student. If it's half an hour, if it made it half a lecture. Right, 1,800? I think my math's right there. 1,800 requests per student, and if there's 50 students, that's 9,000 requests. We might have sent 10,000 requests to my server just by having 50 students use that chat app. So the bandwidth adds up quick. The number of requests you're handling adds up very quick if you're using polling like this. I didn't do the math before lecture, and I did it after. I'm like, holy crap, we sent probably over 100,000 requests in a fairly short amount of time. So limitations. Solution, long polling. Long polling, none of you have to implement this semester. I just want to talk about what it is because you're likely to hear about it in your careers. It's the reason I spent so much time on YouTube looking at those requests. They're using long polling at Google. So most people aren't going to use polling these days. It's pretty archaic. It's pretty bad practice, I guess. By most people, I mean big companies, big corporations with millions of users, or any reasonable number of users, 50, like I just mentioned. I use polling still when I have one user, like this is just polling at intervals of 2 seconds to check if it's time to play music or not. I still use polling, but I have one user, and it's not even making web requests. Long polling is what you use when you want to reduce that bandwidth and get some better performance out of this. So what long polling is similar to polling, except whenever the server gets a polling request, it's just going to hang. It's just going to sit there and do nothing intentionally. So the structure of this is client makes a long poll request. Server gets that request and asks one important question. Is there any new information to send to this user? So for our chat app, is there a new chat message that I haven't sent to this user yet? If the answer is yes, respond right away and send that new information to the client. If the answer is no, you just sit there, and you just sit there, and you just sit there. And then if somebody else sends a chat message, you get a request to send a chat message, then the server says, oh, new chat message. And it goes to all these HTTP requests that it's just sitting on, that's just waiting, and that are kind of in limbo. It goes to all of them and immediately responds to all of the requests with the new information. And there might be some buffering. In practice, there's buffering and things like that. But it's going to respond when there's data available. So the client sends a request, and as soon as there's information ready, we respond to that request. So the client gets that information as soon as possible, as soon as it can. And if some certain timeout, some certain amount of time passes, and there's no new information, the server responds to all these long polling requests and says, hey, I got nothing for you. The client gets that response that says, hey, nothing for you, and then immediately opens up another long polling request. So in effect, every client always has a long poll request sitting there open at the client or at the server, waiting for information. So whenever the server has information, it just responds to those long polling requests and then gets the next long polling request. So this is a lot more efficient. The interval is a lot longer than polling, and you don't have to flood the internet with all kinds of requests over and over like you do with polling. So it's much more efficient. And you also get very fast response time. You get your information when you want it. So this is common. We just saw, not even that surprisingly, that YouTube is using this. So we get lots of, I basically said all that. We're actually going to use WebSockets to get the same effect in this course, but I want to make sure you know what long polling is, because you're likely to see it. You'll still see this in your career. Obviously, if you work at YouTube and work on their chat, you're using long polling. Facebook still uses it for their chat, which means all their subsidiaries probably still use long polling. More than likely, it's probably the same architecture. Long polling is still out there. You're likely to see it. One very nice advantage with long polling over WebSockets is it's going to work with even the oldest browsers. Long polling is just HTTP. That's it. It's just using HTTP in a somewhat creative way. So it's very compatible, very good on the compatibility score.